So this is the Mastercam 2020 Swiss Programming Overview webinar hosted by myself, Matt Sump, and I also have Chad here, one of our senior applications engineers out of our Indiana office. Let's get into first kind of a general overview of Swiss programming in Mastercam. So what is it? It's essentially using Mastercam lathe and mill to program Swiss CNC machines, and we're currently handling it via basically approved custom post processors that are being distributed now by Mastercam Corporate. So that's a big part of what Chris has been involved with, is getting all these configured and set up and working with the post department to basically make these as reliable as they can be before they're ever delivered to you. And you know, a lot of you that have used Mastercam or really any CAM system, there's always going to be some fine tuning or customer preference tweaking done after the fact or after the sale. But you know, the more feedback we can get from the machine tool manufacturers and working with, you know, just experience and getting these dialed in as much as possible has been a big part of this. So what happened to Swiss Expert? And I made sure to put this in here because a local tech school of mine recently added some Swiss equipment. We were setting up with a post, and I got them set up with a post, and then they asked me where the download was for Swiss Expert. And I realized, you know, there probably wasn't ever any communication about this, but Swiss Expert essentially does not exist going forward. The current plan is to eventually get Swiss equipment into the mill turn product with Mastercam. And if any of you aren't familiar with the mill turn product, you know, that's currently geared mainly around upper B, lower turret, you know, Integrex or Multis type CNC equipment, or, you know, twin spindle, twin turret, where a lot of syncing is involved. And, you know, obviously we want to get there, but a lot of that technology that was in the Swiss Expert is being moved over. And, you know, the real reason I heard why that Swiss Expert kind of got put to the wayside is it didn't have the feel of Mastercam. And, you know, the big benefit of Mastercam is just the ease of programming and being able to cut what you want, when you want, how you want. And that flexibility just, you know, it needs to be there for us to be behind a product. And so that's why we've kind of reconfigured this and are offering the solution we are today. So what do I need to use it? You need at least a Mastercam lathe with a base mill seat at a minimum. So just due to the amount of live tooling capability of any Swiss CNC, you need more than just the lathe product. So if you have lathe and mill 3D, that's fine too, but you at least need both. Or if you're on a network license, you would need to pull both licenses in order for that to work. And then it's not required, but we definitely recommend the Simco Edit Pro for the multi-channel viewing and syncing, as well as the GCode backplot that's in there. So what are the limitations? So the biggest limitation of this is going to be the simulation part. So we're not going to do full machine simulation like you see in mill turn, or like what we offer with a lot of our 5-axis mills, or even the base mills that are built in to Mastercam by default. But as we get into this, you'll see that we are able to simulate, you know, still in just the regular Mastercam verifier backplot, what I've always called the business end, which is the part to the tool. So then what happens when Mastercam releases Swiss for mill turn? That's a good question, because we don't know when that's going to happen. So we want to make sure we have a solution for you now, because as that survey showed, you know, a lot of you are programming these manually, and there's a lot of benefit that you can get out of moving away from that. You know, just think of it on the mill side, when you went away from using notepad or programming at the controller to moving that offline, you can still see a lot of benefit. But so all I've been told, because obviously there's no specifics yet, but there will be a pathway for people that do get these custom post processors for the lathe and mill product to transition to mill turn if and when they want. But you'll see as we go through the demo and get a little deeper into this, some people may not even need that, quote unquote eye candy of simulation. So then what machines are supported? So like I've been saying, Chris has been a big part of this and making sure we have as deep of a library as currently possible. And this is just kind of a quick list. Don't bother to write all of this down. Feel free to contact us with your specific equipment. But the short story is we support a lot of the most popular Swiss that are out there. And a lot of these I kind of try to group together, like the SR series of Star. We support basically most of those. Same with like the L series from Citizen, where they have a lot of variations in size and some minor options on the machine. But that's the nice part about a Mastercam post, is that our post can typically support machines across a series as long as the configuration and like head or slide setup is the same. So what are kind of the benefits to this current solution that we're offering inside of Mastercam? So the first is obviously if you're either manually programming or you're hand editing MP fan or MPL fan, I should say, programs. So you're just taking a generic FANUC program out of Mastercam lathe and then adding in all of the additional codes that the Swiss may need, or splitting the program then up into the 3 code streams that the machine needs, or 2 depending on the piece of equipment. Next is, if you're already familiar with Swiss equipment programming and just the methodology about how they work, this can be a very simple transition for you. What we've seen is if a current, say, mill lathe customer that's programming live tool lathes, if they get a Swiss and know the Swiss or already have one in their shop and then add one of these posts, we typically just do a couple hour online training session with Chad, who will be doing the demo today. So once we kind of show you the nuances of kind of some programming tips and tricks, and then how the post interacts with the tool paths, people are basically off to the races. And the next part here is, I just put it as reliable G-code. So another strong point of Mastercam over the years is just been the flexibility of our post processors. And then also having a team, Norbert, Chad, and Mitch are all on the post team here at ShopWare. And as long as we're getting feedback from the customer, we can make a post do pretty much anything you want it to do. I rarely hear the word limitation or can't happen in Mastercam posts. And I've had customers switch to our Swiss product from some of the dedicated Swiss cam softwares out there because the simulation looks all great, and then they post it out and go to load it on the machine, and it's error after error, or the tool's not doing what the simulation was showing. So there's definitely a trade-off there. And the next is what I was talking a bit about before, is just the ease and efficiency of Mastercam programming. That's the nice part about Mastercam, is I can go, kind of get into the weeds and set up my stock and my jaws and 3D tools and really go down that route, or I can draw a 2D profile in 5 seconds and slap a generic tool on there with the correct insert, and I can have G-code in 60 seconds. So that's just the nice flexibility that Mastercam offers, is kind of both ends of that spectrum as far as how much sort of job setup and process planning you want to do before you're actually getting a program out to the machine to make some chips. So what are the potential challenges of this? And like I've mentioned already, I guess it's my second bullet point, but the lack of complete machine simulation. We obviously know that that's a drawback to this, and that's why it's not a product for everybody. But I think you'll see where that can fit into your process, and if if it doesn't, that's why we just want to be upfront and honest about what we can and cannot do. But also what I've had a few potential customers contact me, and they've never had a Swiss machine. They're going from a 2-axis lathe to a 11-axis Citizen, and they've never used a cam system before. I don't know if that's something you would want to jump into right away. So that's why I just listed that as a potential challenge. And no questions still yet, but feel free to chime in if you do. But want to keep this moving along as well. So the last part here, and think of this as more going to be an overview of what Chad's going to cover, or just touching on some of the stuff that he'll get into in the demonstration portion. But what are some of the features? So 3D tools are fully supported. Since we're just running in regular Mastercam lathe, all the new 3D tooling support that's out there, especially with getting into Swiss equipment and, little tiny boring bars and stuff, making sure that they clear is nice to be able to set that up. And if anybody doesn't have any exposure or experience with the 3D tools, we will cover them a bit in our 2020 webinar coming up in a couple weeks. And then we've also done a couple prior webinars on our YouTube channel that get a little more into 3D tools. Or if you just Google, like the nice part about anything in Mastercam, if you just Google Mastercam lathe 3D tools, I'm sure there's a bunch of videos out there about it. Next is controlling specific machine features via miscellaneous values. So if any of you haven't been in this screen before, it's typically on the first tab of any tool path in the lathe side of Mastercam, and then a little farther down on any of the mill or live tool paths. But we can essentially have stuff built in here already, and then also add stuff based on customer feedback to this section. But a lot of these Swiss posts will come default with a screen like this, where you can insert weight codes before or after the op and kind of control some spindle syncing and some other specific features depending on the particular Swiss machine. And then also then the 3D verify of the tool bushing in the part. So while we're not getting machine simulation, we're still able to simulate the tool to the part. That's really about the only major drawback to this, is as opposed to the stock going to the tool like it does typically in a Swiss machine, the tool's still going to go to the part like it does in regular Mastercam lathe. But really you're checking for tool clearances and retracts and inserts, depending if you set up how you have your tool set up and if you're using the 3D tools. And then lastly is the multi-channel G-code view with the Simco Edit Pro. Chris from Mastercam also let me know that is now supported in the Code Expert that's built into Mastercam. So you don't absolutely need the Simco Edit Pro for the multi-channel viewing, but we've all used it here for years, and the backplot is also a nice feature. I had one question from Alfonso, programmable B-axis on Swiss, specifically Citizen. Chris from Mastercam might be able to answer that a little better than me, but I know looking at the list, and I'd have to look at the complete list, some B-axis on particular machines are supported and some aren't. So in that case, definitely reach out to us directly with your specific model, and we can talk more about it. But Chris actually chimed in just via chat here. Not yet on Citizen, but yes on Tsugami and Star B-axis. See, Alfonso, fortunately, it's still the same. I think when I was out there back in March, still in the works. And now it's demo time. So hopefully that was enough PowerPoint, all of you, for one day. I think I only had 4 or 5 slides there, so hope it wasn't too bad. But what I'm going to do now is I'm going to hand it over to Chad Wright, one of our senior applications engineers down in Indiana, and the ShopWare resident Swiss programming guru.
Okay, hopefully you guys can see me. Can you see me okay, Matt?
Yep, things
Okay, great.
on my end, and you sound okay. So.
Okay. Like Matt spoke of, I'm going to show you a little bit about this. I'm just going to do a quick demo on a simple part. I'm not going to get too ridiculously technical, but I want to show a few of the differences between regular lathe programming and the Swiss programming, just to show a couple specifics. We're going to be using today a Star SR32J post. That's a common one in our area. We see a lot of them. And that's one I had handy, so I'm going to use it. One of the first things I want to point out is one of the differences. Normally on a regular lathe, we start out with part only in one chuck, and then we transfer it over to the other. In Swiss, it's a little different. We have to have part geometry in both. So you see here, I've got one in the sub and one in the main. So you need the geometry both. That's so we can work simultaneously on both spindles. And generally in Swiss, the last operation we do is the cutoff and the transfer. So that is a little bit different. The stock setup in here, I'm going to go over that. And I'm assuming that most of you probably use Mastercam lathe, but if you don't worry. It's not a big deal. Our training for the regular lathe will get you about 99% of the way there for the Swiss, because all the tool pathing is the same. Use the same tools like Matt spoke of. The 3D tools are all supported. All the same tool paths, threading, grooving, drilling, things like that. There's just a few specific things for the Swiss, and like I said, a couple hours usually is about all you need on that. So if you don't have Mastercam lathe, our training classes can get you almost all the way there. The first thing we do is set up our stock. In here, it's just a bar stock defined as 3/4 diameter. But one of the differences between this and a regular lathe is going to be the chuck jaws. We need to simulate the guide bushing. So in here, under your chuck setup, you're going to come in and you're going to make it just a rectangle and take the steps out of it. So you got, in this case, we got about a 3.5-inch long guide bushing, and it's about 9/16 thick. And then in here, we tell it the diameter we want to clamp on right there. So that's one of the differences in the stock setup. Not a huge deal. The other thing that's different is all these Swiss posts are going to start out with a lathe stock advance tool path, which is this one right here. This is a common tool path we use to advance the stock out in regular lathe. In here, we're using it for a different purpose. We're actually not transferring the stock in here. We're telling it 0, 0. But the reason we do this is down here, this custom parameter page is available to us for this operation. I know you guys probably can't see the whole thing there, but what this allows us to do is we can input specific parameters for each specific machine on this page. In the case of the Star, we need like the pound 531 variable for the stock diameter. We need the cutoff RPM, which is pound 529, etc. All these values. And this gives us a place to store these values, and we can save them as defaults in regular Mastercam. So when you do repeat programs or you program a new part, when you pull this up, all these values are going to be in here, and you may only have to tweak a couple of them. Saves you a fair amount of time. And these can be changed depending on the machine in here. And this is going to come out in the post. At the top of the post for some of them and throughout the post for others. So that's one of the main differences. We always start off with this operation. So I'm going to bring up the fully programmed part right here. Like Matt mentioned, one of our limitations is the simulation. We can only show one tool at a time. We can't show, working on both or multiple gangs, but we feel that the reliable G-code, that the post more than makes up for that. We've had several people that have gotten this, and they've been just very happy with the code on it. So, but I'm going to show you a little bit of the process here. For this first side, we're doing ops on the main spindle right here. I'll zoom in a little bit. So we're going to come in here. We're going to do a spot drill, and then a drill, then come in with a regular D&MG 432. We're going to face it off, then turn the OD, come up here, and this is the old, what we call the classic backplot right here, and lead off on that. Then we're going to cut out this relief groove for the threads right here. Just a standard grooving tool path, and again, same tool paths using in regular Mastercam lathe. We're just programming just like we would for a regular lathe right here, no difference at all. And then the thread. Then we're using the milling side, which Matt spoke of. You need mill and lathe for this because of the capabilities of the machine. You need both licenses. So this is using the mill. So we're coming in here and in milling around these flats on the hex on this part. And then we'll top off the shoulder back here, then drill a cross hole in it. So we're spotting it and then drilling it. Okay, so that's pretty much everything on that first side. Now, for those of you wondering that maybe haven't programmed a lathe before or whatever, here's what's actually required for this tool path right here, like this lathe finish. This is all the geometry that's actually required right here, is this just 2D profile right there. You can do it off the solid model if you want. I've got the solid up there. But like Matt spoke of, we can go either high end or low end. You can go with the 3D model, or you can go with just the wireframe. So on here, that's all that's required for this finished tool path right here, is this. I'll bring it in so you can see that. It follows that based on your parameters. Now, one of the things with a Swiss is you've got two channels. You've got your main and your sub. And how that's determined is going to be how you program it. In the tool path, inside here, there is what we call axis combinations. And those of you that have regular lathes, you're familiar with this down here. This is normal. If you've got multi-turrets or multi-spindles in here. But we got, for this machine, we've got left upper, and right lower. So the two right combinations are going to be working on the sub spindle. The left combination will be working on the main. Now, when you go to post, the post splits this up into two channels. So everything on the left is going to go to channel 1, or whatever channel you tell that number to be. And everything on the right is going to go to channel 2, again, or if you want to change the number, you can. So that's how it determines how these are split up. So for programming purposes, normally you're going to do all the main work first and then the sub work and keep them in different groups. But as long as you have the ops for the main in their correct sequence and the ops for the sub in their sequence, you could actually put a sub spindle op into the main group if you wanted, because when it posts, it would split it out into the separate channel. Now, a couple other things I want to point out in here on this while we're in here. As Matt pointed out, there's a missed value page. So if you need weight codes on these, which this part doesn't require, it's pretty simple, and the slides won't hit each other. But if you need them, there are 4 available. Right here, you can put them in. There's 2 before the op and 2 after the op. In this particular machine, it uses like M101, M102, M103. So whatever you put in that box is going to come out in the code in there. The other thing I'd like to point out also is they have accounted for, this is something that other CAM systems can't do, but we can here. You can change the boring axis. A lot of times on a boring bar, you'll want to bore with the y-axis due to clearance issues with another tool or simultaneous op going on or something like that. This allows you to bore X positive, X negative, Y positive, or Y negative, and that's just a selection in there. This gives us options in here that are passed on the post that allow us to do things that you can't do with another CAM system in here. So the sync is available if you need it in there. Okay. The sub spindle ops right down here. We'll zoom in so you can see that. These are all programmed with the right axis combination. So it's coming out on the sub. So it's coming in here. It's doing a chamfer, a spot drill, a regular drill, and then it's milling the flats around the OD right there. Now these flats, the milling for the flats was picked directly off the solid model right here. So no wireframe required for that. So you can mix and match where I use just wireframe on the main, I can use solids on the sub, or vice versa, or on both. So you get a lot of flexibility with Mastercam and the ability to do that. So we talked about some of the differences. The first one is your stock setup and your stock advance. That's always going to be first. The other thing on this is your cutoff and your pickoff, where you're moving over to the sub, are always going to be your last operation in the Swiss. So that's a little bit different. That's why we had to have the stock in the sub spindle, or the part, excuse me, in the sub spindle to start off with there, so that we can program on it. But down here for your last operation, it's going to be a cutoff. I'll back plot that. So comes in here, does a pre-position, comes in, grabs the part. There's the guide bushing coming up and grabbing the part. There's your cutoff tool coming down and severing the part right there. So you get a fair amount of simulation right here. You can also, like Matt mentioned, go into Verify. We can do a 3D simulation. So I'll bring that up. This can give you a lot of times things you don't catch on the other one, which is nice. Now in here, one thing we need to do different over and over in Mastercam is turn on the workpiece right here. That gives us the stock in this spindle so you can actually see it cutting on that spindle down there. Let me slow this down a little bit. Now let me get that a little slower here. I'm still too fast. So there's our same ops that we saw on the main, or out in the main screen. And the cutoff over here. So like I say, we can't simulate multiple tools at one time, but you get a pretty good idea of the simulation. And in here, this is going to catch most of your errors that you're going to see in here. Like if you run into the guide bushing or you cut through the part or something like that, you're going to see it in here. So we are limited on the simulation, but we do have simulation in here. So, and at the end of the day, normally reliable G-code is what's really most important on that. So that's a quick overview of that. And you notice we did work on the main, we did work on the sub, then we went back into the cutoff pickoff. That's back on the main, so you can bounce back and forth on these. Like I say, the big thing is you just want to get your sequence of your ops for each spindle in the right order. Now for the important part, when we actually generate the code, that's going to be taken care of in here. And I'm just going to generate this live. Come in here, tell it to generate the G-code. It's going to come up and ask me what I want my channel numbers to be for the different heads. I'm telling it 1 and 2. And it's going to pop up in here. And like Matt mentioned, we have a multi-channel view. This one I don't have any sync codes in, but I'll bring in a file here in a minute and show you live a little better view of that. But I'd like to point out some of the G-code stuff right here. A lot of the parameters we put in at the stock advanced there, they're coming out here. There's your pound 531, your pound 529, pound 530. A lot of this stuff is built in automatically to the post, so it saves you having to do hand editing, things like that. Here we're doing the M98 subprogram call for safe cutoff, broken tool cutoff check. Then we're getting down into the ops right here. Also like to point out on the sub channel, on channel number 2, they put block skips in front of all the operations. This allows you, when you're running your first part, you can turn the block skip on. That way your tools aren't running over on an empty spindle on the sub there. And coming down here. So other thing is there's a lot in the cutoff routine that's automatically put in for you right here. So a lot of the syncing, RPM syncing, spindle syncing, Z's syncing, things like that are taken care of for you automatically in there. So very nice option in there, very good code on this. So I'll bring in a little better program to view the multi-channel here. Get that. So for the multi-channel, basically that's enabled. That's in the Synco Edit Pro, which for me, for $250, it's a no-brainer. The backplot feature is worth that for, you know, it's worth 3 or 4 times that price. You just come in here, you turn that on, tell it which file you want to use for channel number 1 and channel number 2. If you have more than that, it actually does support more channels as well. So here we go. And these are synced up by the M codes. On these, I've got M102, M106. And you can see down through here, it syncs the ops and gives you a nice space between them down here. So there's where the M108s match up. So on this, a little bit of a Simco sales plug here. If you're doing hand programming, I'd highly recommend this. Would be fantastic, because right here, let's say I want to change the sync point right here. I want to make this 1. It syncs up in real time right here. So very handy in there. Okay. So that's a Simco multi-channel view. So that's a brief overview of the Swiss. Hit us up with, let's see, we've got a question here. Change integer 1 and post to show new stars G266. Not sure about that in there. But that's a brief overview of how all this that goes. Again, you're going to use your regular lathe, Mastercam lathe programming, and just do a couple of different things, and then you're off, to the races on that. So you guys hit us up with questions. We've got to answer. And with that, I'm going to turn it back over to Matt.
Thanks, Chad.
Mm-hmm.
Appreciate it. Yeah, I think that question was actually from Chris at corporate, but it looks in the stock advance options, if you change one of the settings there, for which one is it? Integer number 1 to a 1, it supports that star's new G266 function, which Chris might be able to explain what that is. I haven't heard of that before, so. Or if Chris, if you want to chime in and explain what that is, feel free to.
We'll output the code right here.
Okay.
There's the G266 right here.
So it basically puts all that information on a single.
So quite a bit of difference right here I see in the code. So that's an option you have right there just by changing the one integer in there on that.
That's cool. Thanks again for all your time, and everybody have a good rest of their day.